All right, let's continue our discussion. And what we are going to do now, we are going to run a quick program or write a quick program with interfacing our hardwares. And this is going to be one single LED blink program. And I'll first show you the program, then we will talk about the baseboard connections. All right, so let's go to our directory, and I'm going to say single let py. So as you can see, very pretty simple program. We are importing GPIO as GPI RPI.GPIO as GPIO. We import time, right, because we are going to use a time function in our program. As you can see, I'm using port 21, GPIO pin 21, and assigning it as a variable LED. Okay, as you can see, GPIO set mode is set to BCM. That means you can reference your GPIO pin using the GPIO number, not with the actual reference number. And I'll talk more about this in a moment. Okay. So there are two ways you can do reference your baseboard. You can either say GPIO.BCM or GPIO.board. But in our programming, we are only going to use GPIO.BCM. Okay. Then what we are going to do, we are going to set up the LED 21 as GPIO out. Okay. You can also configure in various like Sonar or DHT. You may have some pins which is GPIO input, but for this program, we just want to supply current using this LED 21, and hence GPIO is set to out. So what we are doing, we are saying that okay, GPIO out true, that means provide a high voltage, sleep 1 second, this is 1 second. So provide high voltage for 1 second, then again LED false. So turn off the voltage or supply no voltage, and then sleep 1 second. So basically 1 second up, on, 1 second off, 1 second on, 1 second off. So that's what we are going to do. Now let's first discuss the BCM and board confusion. So GPIO, or just say pin out. Okay. As you can see, these are all various pin, start from 1 all the way to 40, right? So either you can reference at 1, 2, 3, 4 and so on. And if you do so, that means you are using GPIO.board configuration. Or otherwise, what you can do, you can just reference the pins with their name. And as I have shown you in previous video, so each pin has a certain tag associated with that. And if you decide to call them with their name, that means you are using GPIO.BCM. As you can see, physical pin 1 is 3 volt. Physical pin 3, actually, if you are using GPIO.BCM, you can say GPIO2, right? So this is what we are going to use throughout our programming. All right. Now let's go back and run the program. So Python 3 single LED py, and as you can see on screen, the LED started blinking. Okay, and I know we have not spoken about the connection yet. I'm going to do that in a moment. Okay, so to terminate the program, I'm going to send a keyboard interrupt by using Control C, and here you can see the program is interrupted and LED is off. So when you interrupt the program, LED will be stuck in the state where it was last. Okay, so if it was off, it will be off. If it was on, it will be on, and we will watch it again. Okay, now let's quickly talk about the connections first. Okay, so as you can see, I'm using GPIO 21 in my program, and that is pin number 40. Okay, so this orange wire, this actually represent GPIO 21, which is going to GPIO physical pin 40. And then we have to supply the ground voltage, of course. And for ground voltage, what we are using port number 39. here, pin number 39. So this black voltage denotes a ground. Okay, black wire denotes a ground. And how to connect your LEDs? As I have shown you, discussed before. So LED, when you pick up an LED, you will see there are two legs. One is a little bit, okay, let me see where you can see it properly. Okay, yeah, they are bit transparent. So as you can see, they have two leg. One is longer, one is shorter. The longer leg is anode, and that's where you need to connect that to a voltage. Uh, that is your GPIO pin out, and the shorter one is cathode, which connect to ground always. All right. So that's how I'm going to place it on my breadboard. The shorter pin connected to ground and longer pin connected to a GPIO pin out. Also, keep in mind that uh, these LEDs, they are pretty, I mean, not that great quality. So always make sure that you interface them with a resistor like this. 330 ohms resistor should be fine. Okay, so don't supply a direct current. Always use a resistor. Uh, and one end of the resistor will be connecting to GPIO pin. Another end of resistor will be connected to the anode of your LED, and that's how you're going to make the connection. uh, LED and GPIO together, resistor together. One end will go to ground, one end will go to positive voltage. All right, so many of you already know that, so sorry if I am like rat holing on this, but if you are not aware, this is how you need to connect. All right, so now let's run this program one more time. As you can see, LED started blinking. Yes, right. So while it's blinking, what I'm going to do, I'm going to just send an interrupt. Okay, I want to catch it point in time, okay, where it is on. All right, so let's send an interrupt. Right, what I'm going to do, I'm going to just quickly, for sake of demonstration, I'm going to increase the hide timeout. Okay, and obviously you can use Python Thonny IDE, but I'm doing SSH, so I'll edit it with the text editor. So let's say 5. Okay, this is good. Let's save it, step out, and run it again. Okay, as you can see, it's on for 5 seconds, then gonna go off and again turn off for 5 seconds, and I'm going to send an interrupt. The purpose of this demonstration is to show you that if you interrupt your program, or you stop running your program, the LED will stay in the previous state. So if it was on, it will stay on, whether no matter if the program is running or no. So this is not very ideal, right? So you don't know if your program is running or no, because the LED is always on. So what you can do, you can always do a clean exit. And for clean exit, what you need to do, I just modified this program a little bit again. And for that, what you need to do, you need to add a final GPIO cleanup function. So what I did, I just modified this program, and now I'm saying try GPIO output on for 1 second, off for 1 second, but no matter what, when you exit with GPIO cleanup. That means the pin number 21 will be reset. Okay, so now let's run this program. It's just a small enhancement of that earlier program, but it's much better because it always do a cleaner exit. All right, as you can see, the LED is blinking on and off, on and off, and now I'm going to send a interrupt. As you can see, now it's off because it did a GPIO cleanup. All right. So this is a very simple program, or first program of this IoT fun series. I hope you like the video and you can follow along with me for next more interesting experiments. Thank you.